For generations we've looked up at the night sky and wondered about our place in the cosmos, searching for meaning in the endless expanse above us. Where did it all come from? What secrets are hidden in the darkness between the stars? How did the first stars ignite, lighting up the universe for the very first time and forging the elements that would one day make life possible? How did galaxies emerge from the cosmic darkness, assembling into the grand structures we see today? For decades, even our best telescopes like Hubble couldn't see the universe's first light, stretched and reddened by billions of years of expansion, hidden in wavelengths our eyes could never see. But now, everything has changed. A new era of discovery has begun. The James Webb Space Telescope, or JWST, is our new time machine, designed to capture the faint ancient infrared glow from the dawn of creation, peering farther back than ever before. Launched in 2021 after decades of planning and international collaboration, JWST is finally letting us peer into an era we could only imagine before, opening a window to the universe's earliest moments. The data it's sending back is revolutionary, challenging our assumptions and revealing a far more complex and dynamic early universe than we ever dreamed possible. Every new image holds the potential for a groundbreaking discovery, each one a glimpse into the unknown. We're not just adding footnotes to our textbooks, we're rewriting entire chapters, reshaping our understanding of how everything began. JWST is a testament to human curiosity and ingenuity, uniting thousands of scientists and engineers worldwide in a shared quest to explore the unknown. With this telescope, we finally turn to the universe's very first page, reading the story of our cosmic origins in light that has traveled for billions of years. The journey to understand where we come from and what else might be out there has truly begun, and the universe is revealing its secrets, one image at a time. Before we dive into JWST's discoveries, let's take a moment to recap our best story of the universe so far, the Big Bang Theory, our most successful explanation for how everything began and evolved. About 13.8 billion years ago, all of space, time, matter, and energy burst forth from an unimaginably hot, dense point, an event that marked the true beginning of everything we know. In those first moments, the universe expanded rapidly and began to cool. It was a searing, opaque soup of particles and energy, so dense that light itself was trapped, unable to travel freely through the chaos. After about 380,000 years, things changed. Atoms finally formed, allowing light to break free for the first time, leaving behind the cosmic microwave background, a faint afterglow that still fills the universe and gives us a snapshot of those ancient times. What followed was the cosmic dark ages, a long silent era with no stars, no galaxies, just vast cold clouds of hydrogen and helium drifting through the darkness. Over millions of years, gravity slowly pulled these clouds together, compressing them until, at last, the first stars, known as population 3 stars, ignited. These were giants, burning hot and living fast, lighting up the universe for the first time. Their spectacular deaths as supernovae scattered heavier elements into space, enriching the cosmos and paving the way for new generations of stars, planets, and the very first small galaxies to form. Over billions of years, these early galaxies collided, merged, and grew larger, gradually building up the majestic spirals and ellipticals that fill the universe today. This is our standard model, a slow, orderly cosmic construction where complexity emerges step by step over eons. It was a good model, built on decades of careful observation and the best evidence we had, guiding generations of astronomers in their quest to understand the cosmos. But now, with the launch of the James Webb Space Telescope, we're seeing a universe that's anything but slow and simple, one that's full of surprises and challenges to our old ideas. The early cosmos, as revealed by JWST, was far more dynamic, crowded, and astonishing than we ever imagined. Galaxies forming faster and earlier, structures appearing where none were expected. The story of our universe is about to change, and we're just beginning to turn the page. Imagine expecting to find tiny villages in ancient ruins, but instead you uncover sprawling cities. That's the shock astronomers felt when JWST looked into the early universe. Our models predicted only small, faint galaxies in the first billion years, nothing big or well-structured. But JWST found over 100 bright, massive galaxies from this era, some with mature structures far beyond what we thought possible. It's been called the impossible early galaxy problem. How did the universe build such large structures so quickly? Maybe galaxy seeds were bigger, or gas collapsed into stars more aggressively than we thought. And it's not just a few outliers. JWST uncovered thousands of hidden galaxies, many extremely red and mature. Scientists are now rethinking the recipe for galaxy formation. The universe, it seems, was in a hurry to get the lights on. Our models need a major update. The quest to find the most distant galaxy is a quest to see the universe's first moments. With JWST, we've leapt further than ever before. In July 2025, astronomers announced MOM-Z14, the most distant, oldest galaxy ever confirmed. Its light has traveled 13.5 billion years, showing us the universe just 280 million years after the Big Bang. MOM-Z14 isn't just old, it's surprisingly bright, bustling with star formation. This fits the trend. Galaxies formed earlier and faster than we thought. The cosmic clock was ticking much faster. Even more surprising, JWST detected elements like carbon and nitrogen in MOM-Z14. These elements are forged in stars, so there must have been an earlier generation of stars that lived and died before MOM-Z14 stars were born. This discovery pushes the timeline for the first stars even closer to the Big Bang. The universe's first chapters are being rewritten. Just as we pictured the early universe as a non-stop star factory, JWST surprised us again. In 2025, astronomers found over a dozen galaxies that had already stopped forming stars just a billion years after the Big Bang. Nicknamed Sleeping Beauty galaxies, they mysteriously went dormant during the cosmic baby boom. This was thought impossible. There was plenty of fuel, so why did they stop? In today's universe, giant galaxies can be quenched by supermassive black holes, but these early galaxies were small and shouldn't have shut down. Something else was at play. This forces us to rethink how galaxies grow and evolve. The early universe wasn't just a one-way street of starbirth. These dormant galaxies are a crucial new piece of the cosmic puzzle. What put these Sleeping Beauty galaxies to sleep? The leading theory: galaxies can be their own worst enemy. Intense starbursts create massive blue stars that explode as supernovae, unleashing galactic-scale storms. This stellar feedback heats and blows out gas, halting star formation and sending galaxies into a dormant phase. But this slumber isn't permanent. After about 25 million years, gas cools and falls back in, reigniting star formation. The result? A stop-and-go cycle. Galaxies flicker between bursts of activity and quiet slumber. This changes our picture of the early universe from smooth and steady to dynamic and chaotic. Some galaxies matured quickly in intense bursts, explaining their surprising early development. JWST has caught galaxies in both their on and off states. The early universe was a far more intricate dance than we ever imagined. Our models must now account for this cosmic rhythm. One of cosmology's greatest quests is finding the first stars, population 3 stars, forged from the Big Bang's hydrogen and helium. These giants lived fast and died young, seeding the cosmos with heavy elements. We've never seen one directly, they're too distant and ancient. But JWST lets us see their fingerprints, the chemical ash left behind in later galaxies. In MOM-Z14, JWST detected carbon, proof that an earlier generation of stars had already lived and died. This discovery pushes the dawn of starlight even closer to the Big Bang. The cosmic dark ages must have ended much earlier than we thought. Population 3 stars may have ignited just 150 million years after the beginning. Thanks to JWST, we're seeing the echoes of the universe's true first light. We're closer than ever to witnessing the moment the cosmos truly woke up. When discoveries like these emerge, it's natural to wonder, are our old theories wrong? As physicist Michio Kaku reminds us, these are moments of excitement, not failure. The Big Bang's core idea, an expanding universe from a hot, dense state, remains solid. What's changing are the details, our models of galaxy formation, star birth, and cosmic timelines. JWST is turning our pencil sketches into high-resolution photographs, revealing features we never imagined. Science thrives on this process, adapting theories to new evidence. The Big Bang isn't in jeopardy, but our sub-theories are getting a much-needed upgrade. This is the thrill of science. Every answer leads to deeper questions. The universe is more creative and complex than we ever guessed. Each discovery is a celebration of our ability to learn and adapt. Has JWST debunked the Big Bang? Absolutely not. In fact, the discoveries made by the James Webb Space Telescope have only deepened our appreciation for the Big Bang Theory and the mysteries of our universe. The Big Bang remains the foundation of modern cosmology, the starting point for everything we know about the cosmos. What JWST has done is sharpen our view of the universe's first billion years, revealing a far more dynamic and surprising early cosmos than we ever imagined possible. We found mature galaxies forming earlier than expected, challenging our timelines and pushing us to rethink how quickly cosmic structures can emerge. We see galaxies that flicker between bursts of star formation and periods of slumber, hinting at a universe that was restless and full of surprises. And we're detecting chemical traces of the very first stars, the building blocks that seeded everything we see today. These aren't contradictions, they're the rich new details we can finally add to the Big Bang story, making it more complete and fascinating. Science is a process of refinement, building on what came before, always questioning and improving our understanding. Our previous models were the best we could do with Hubble's data. They were stepping stones, not final answers. JWST is now giving us the missing pieces, allowing us to see further and deeper than ever before. The universe is an unfolding story, and we're privileged to read its earliest chapters page by page, discovery by discovery. Every JWST image is a postcard from the dawn of time, filled with mysteries to explore and questions to answer. Thanks to JWST, our journey to understand the cosmos is more exciting than ever, and the story of our universe continues to unfold in ways we never expected.